Let's take a look at this. Yesterday, we were doing patterns with blocks. And Cole, if you remember, asked this awesome question, how do we do it if we don't have blocks? So Cole, today, all your prayers will be answered. All your questions will be, well, not all your questions. I can't help you with the meaning of life, at least not right now. But we're going to look at how to come up with a rule. Remember, we talked about this yesterday. This is big. Coming up with a rule is big. We're going to do it from equations. We're going to do it from words. We're going to do it from problems. We're going to do it from patterns of blocks, like pictures, all different ways. Coming up with a rule. Before we get into that, and so some of this is like stuff that we're going to work at over time. You know, so you want to learn sort of some of it today, but if you're not an expert, you'll have more time to become an expert, but you have to keep working at it. But one thing that I want you to, we'll think about now and we'll continue to think about is, why is coming up with a rule important? We have talked about this. So it's a rule that helps us talk about a pattern. Why is it important? Okay, let's do the first example. We're going to revisit this question. Patter. Patter. Recall this patter. Oh, that's what you call it when it looks like a cross. Call it a patter. That's a joke. Okay. This is what we did with this pattern yesterday, at least for some of us. Okay. So sometimes patter. Sorry, you're right. Patter. For this one, we don't all have to see it the same way, but we all have to get to the same ending eventually, which is like our rule and understanding the change and that sort of thing. So a lot of us looked at it as there was a center block that we were starting from. There's always that one. And in this case, we had 4 arms, and each arm was length 1. And in this case, we have 4 arms, but each arm is length 2. And in this case, we have 4 arms, but each arm is length 3. And the length of the arm matches the figure number, so that's important to notice. And there's always 4 of them. That's kind of the pattern, right? So we saw this happen yesterday. So we did this table of values. How many is in the first figure? How many blocks in the first figure? 5. How many in the second figure? 9. Third. What's the change? 5 to 9 is? Adding 4. 9 to 13 is? Elena? What's 9 to 13? What did we do to do that change? What do you think? 4. We added 4 again, right? We're adding 4 every time. How does that match our picture? We're adding 1 to each arm each time. So we're getting 4 new ones each time we go up a figure number. So what would happen when I went up to the 4th? We extend the pattern. It's going to be 17 because we're going to add 4 again. We know that. You may have made that pattern with blocks, I don't know, or thought about it. How do I follow it back? Because this is really important, is we always do want to figure out what the 0 number is. There's 2 different sort of ways to think about it. Emma?
5 minus 4.
So I use my plus 4, but since I'm going the other direction, I'm going to subtract 4. Or I'm going to think about it like, what number do I have to add 4 to get to 5? Right? There's both those ways that you could think about it. And it's really important that you always get to the 0 figure number, 0n or 0x. That's going to give us an important part of our rule. Knowing that's where you start. We start at 1 and our arms are growing from there in this case. So we want to know where we start, always, always, always. Has everybody got that? So what is the rule for this pattern? Okay, describe it. We're going to describe it with words. A lot of people were doing this. It's going up by 4 or something like that. But why is this rule not good enough? This goes back to the question that I was asking at the beginning. Why is this rule not good enough? What if, again, this rule was how much you pay for sandwiches for a catering company? And somebody called up and said, I want to order 12,000 sandwiches. Okay, hold on. I'm going to figure out how much that's going to cost us. Okay, so we're going to start with 1. So we add 4. Then we add 4 again. Then we add 4 again. And I got to get up to 12,000. So I'm going to add 4 12,000 times. Who wants to do that? Yeah.
Times 4 by the number, and then you can add 1.
Well, very good. That's exactly the point. Is there's an easier way to do this. And math is often about finding the most efficient way of doing things. Yes, there are lots of ways of doing things, and your way might work for you, but don't we want to be as efficient as possible in the end? We want to get to a point where we can be efficient. So I could start with 1 and add 4 12,000 times to figure out how much 12,000 sandwiches costs. Or like Emma told us, I can change this. I start with 1. And this part of the rule missed that. So up by 4, but we would have to start with 1. So whether you copy this down or not, I don't know. You can if you want, or you can just watch what I'm doing. There's 2 parts to the rule. And there always will be for linear relations, which is primarily what we do in grade 9. What's the change? And where does it start? So whenever you're asked anything to do with a linear relationship, you can start thinking about that. Well, what is the change and where does it start? How do I figure out what the change is? How do I figure out where it starts? Like, it all can boil back down to those 2 questions. Now, some people might think about it in different ways and just think about patterns, that kind of thing. But you can always sort of structure your thinking like, what's the change? Where does it start? So we start with 1, and we're adding 4. How many times? 12,000. Or 18 if you're buying 18 sandwiches. Or 100 if you're buying 100 sandwiches. That's the part that we don't know. Our rule is based on, the cost will be based on how many sandwiches you buy. So N, it would be like our number of sandwiches. And that's going to work out our cost.
Why is it 1 plus 4 and then see over there is 4 and plus 1?
Can anybody tell me something about that? Emma, what'd you say?
Well, 4n plus 1, you could do it really either way because it's all going to be the same number.
Good, thank you. Perfect answer. Doesn't make a difference. How you think of it, you might think, well, I'm doing 4 times n, oh, but I got this 1 extra, so I have to add it on too. Or you might think, I start at 1, and then I add 4. I mean, it's the same thing. It depends on how you think about it. So those are both the same. Now, the other thing we're going to add to these rules today is we're going to be like equal. I'm going to make it b. Why did I choose b? Anybody know? Number of blocks. Don't use n twice. There's some letters we use a lot. There's some letters we don't use. We use n a lot. We use x a lot. You can kind of pick your own letter, but it's easy. It's best if you make it meaningful. If we're talking about cost, we usually use a capital C. Like, there's things we usually do, but really it's, just about communication. So the number of blocks is equal to 4 times whatever figure number you're at plus 1 extra. Again, think about that pattern. It's 4 and times 2, because every arm is going to be length 2 because we're at figure 2. If I get to figure 10, every arm will be at length 10, and I'll have 4 arms. So 4 times 10 be 40, plus 1 more, 41. Right? Easy. That's why we like these rules. It's easy to calculate these things quickly. And then when we graph the pattern, I'm going to start. The start is my start. Right? What was our table? So N and B, 0 was 1, 1 was 5, 2 was 9, 3 was 13, 4 was 17. So I'm graphing these numbers. Here, this shouldn't be X, this should be N, and this shouldn't be Y, this should be like our B, or whatever we called it. And 1, 5 is 1 on the N and 5 on the B. 2 in the N, 9 in the B. 3 in the N, 13. And 4 and 17. What does it look like? A straight line, because remember, I was going up by 4s, and so it was a straight line. And this tells me where the graph starts, and it tells me an important part of my equation, where my equation starts. Put your pencil down and watch for a minute. These are the three, well, there's sort of one more. Sometimes we do it with words as well. But we're going to say these are the three important ways that we talk about linear relationships. Table, graph, rule. Where's the 1 in each of them? There, there, there. Where's the 4 in each of them? Here. I'm going to talk about it here in a minute, and there. Where's the 4 in my graph? When I went over 1, I went up 4. I go over 1, I go up 4. It's the same as the table, over 1, up 4, plus 4, plus 4, plus 4. Right there's 4. It's a little bit harder in the graph. We're going to do more practice with that next week, but there it is. But for today, that you don't really need to worry about that too much or be able to do that. Any questions? What about the back? Yep. Yep. Any questions before we go? You want to know how to do it? You want to understand what we're doing today, what we're noticing? Each of the following tables shows a growth for a pattern in each table. N represents figure number, T represents... This is the same instructions that we were trying to read before when Emma pointed out that we were doing that. I was working on the wrong sheet. Okay, so here we go. How do we do this? So we're noticing a few things. If you think you can do it, you could try, but I'm going to help you the first time around, and then I'm going to let you try the next one on your own. We already have 0. That's good. We need that. That's an important part of our rule. What's our other part of the rule? It's the change. We also want to see if it's linear. 5 to 8 is what? Haley? Awesome. 8 to 11 is? 11 to 14 is? Somebody? Plus 3. Therefore, linear? Yes. That's what. If it wasn't linear, you'd stop. We can't make a rule if it's not linear. We don't know how to do that. If it's linear, we can keep going. So what's our rule? T, which is the total number of cubes, squares, Legos, dots, whatever, is equal to what? Here's one of the parts, the change. Here's the other part. Which part is which? How many times have we added 3? We don't know. It depends on what figure number we're at. So 3 times that. Plus 5, because that's where we start, because that's where it was at 0. So like you could kind of memorize this. This part comes from here, this part comes from here. That's how I make the rule. But it's a little bit nicer if you connect with it, if you make sense of it, if you understand it, thinking about pictures. Here's a little bit of a trickier thing. I'm going to challenge you with this, so I'm going to let you try it right now. I want you to draw 3 figures with dots that might match the pattern. If this was a question from yesterday, remember yesterday I gave you the patterns, like the front side of this sheet. Where did this come from? I drew it. I had to come up with this. If you have the rule, can you draw the pattern? Just use dots. Use squares, circles if you want. Take a minute and try that right now. Okay, so what I want to do, hold on, I'm going to try to make it so I can draw on this. So take a look. The first figure has 5. 1, 2, 3, 4, 5. The second figure has 8. What's the next number? 8. So what's the change? Plus 3. So where are the 3 new ones? Like 1, 2, 3, and then this one bumped over, I guess. And then the third one, see how I've got one new row of 3, and then I've got this one and the ones I had before? See how it kind of shows that pattern? There's different ways you could think about it. But perfect. This could have been a question that we could have used yesterday. Really nicely done. So for one, I want to make sure that my picture matches my table. And 2, if I can make it an actual pattern, that's kind of nice. Okay, so I would start with 5. You might have done this. 1, 2, 3, 4, 5. And then every one of those is going to have that for 5. 1, 2, 3, 4, 5. Those never change. And then in this case, I've added 3. 1, 2, 3. And in this case, I added 3 twice. And in this case, I added 3 times. There would be another pattern. And in this pattern, again, you can kind of see, because I did it in 2 different colors, the growth. Okay, let's do the next example. What do we notice about this one? Okay, so we need to find the change. And we're going to find our rule. It's missing the 0 row. A bunch of people worked ahead and didn't notice that. So I have to go backwards. Now there's no space to do it, but we need to do it. Whether you do it above or do it below is fine. So how would I go backwards? Like this. So what do I get? -1. So this one's going to be a little bit harder to graph, but I can come up with the rule. My rule is going to be T equals, who thinks they know what it is? Emma? 5n minus 1. So there's the -1. And then it's this number times n. Or x or whatever. We're using n because n's up here, right? But I'm just going to point this out. I forgot to do this for the last example. I wanted to do this. You don't have to write this down. If I was going to graph this, oh boy. Yeah, I know, my computer's up to something weird these days. I would start at 5 and I would go up by 3s, right? So this is not a nice graph because there's no scale. It's not on graph paper, that kind of thing. But I know that it's going to start at 5 and it's going to go up by 3. So my change is going to be 3 every time, however much that is. Like I just know a little bit about the graph without even really doing a formal graph. Okay, next one. We're going to do the same thing. Notice again, it's like the last one. You got to do a bit of extra work. Go ahead and give it a try. See if you can do this one. Oh, sorry. What did you find? Elena, did you finish this one? Not done yet? Did you do this first part, 3 to 5?
It's 2.
So I go up by 2. And some people might do this. Okay, so plus 2, plus 2, plus 2. Okay, good. What did I do wrong? Caleb, did you finish this one? Yeah. Julian?
It's not plus 2 each time.
It's not plus 2 each time. Some people assume it's going to be a rule, and once they find the first one, they just cheat and copy it down. Now, if it's linear, you're going to get away with that. But what did I do wrong? 5 to 8 is plus 3. 8 to 12 is plus 4. So there's a pattern. But Damien, what did you tell us about patterns in first differences at the beginning of the class? If the number changes, it's non-linear. I love it. Non-linear. We can't make a rule. Notice in the practice that was just handed out that it says, if you circled linear, answer the following questions to come up with a rule. Okay, so you can go ahead and try a few more of those. We've got enough time.